Okay, we could take about 5 minutes to do this. You should do this regardless, but it's really pretty simple. If we come in to the projects, all we're asking you to do is come in here and either create or generate a wiki page. You can create a new page. I can edit this page, right? This particular page is, well, not particularly written in anything. I mean, it doesn't use anything. This one is written in Markdown. So we could throw in some things like some highlights. Maybe that's italics, I think. And let's save it and look at it again. Ah, no, that's still bold. Hence the reason I published it's only one. Hence why I published the guidelines for you, so you wouldn't have to struggle through this. But you can come in, and it's really easy to generate pages in GitHub that are wiki pages. And let's do a new page. Okay, so I only have the one page so far. And we can do, page 2. There it is. Do a restructured text at the bottom, What is that? Underlines, I think. I may have asked you to do some other stuff in there. It's good to be able to do the other stuff you will be taught on. You will be, tested on the other stuff, I guess is the right way to say it. But, they're just really good and easy ways to do these types of documentation as to what your project is about. And then on top of that, you can even clone this. All right, if we look here, I'm trying to find something that I can write into. Let's come over to this sucker. Right, we could even clone this wiki just separate from the repository, and now we actually just have something that we can maintain identically to the way we maintain the code itself. Right? So it's just the same tools we had before. So somebody who's coming in and playing with your documentation can fix things, can improve things, and they don't have to learn anything else. You've already taught them everything they need to do by giving them, by the very fact that it's the same tool set that you're using to manage your code base. And this, by the way, is Morthy's document. This is his first page. Here's his restructured text example. His is more refined than mine. I think I have some too. Yeah. His was much more elaborate. All right. So what have we done so far? Well, so far we've kind of looked at a couple of different ways of doing documentation. We've shown you some ways to keep it, right with your code. We've talked about the way Python allows you to put it into modules, which is kind of cool. And we've looked at Markdown and restructured text as simple languages that allow us to do things that are relatively pretty. A lot of our notes for this class are written in one or the other of those. But they're also readable, right? You can actually just go through and kind of, even without a restructured text reader or restructured text engine, you can actually read those. There are other things as well. You'll see that some of our documents are written in HTML, so it's interesting to go through, and you should be able to do the CSS tutorial. CSS is the styling behind an HTML file, so you can specify the backgrounds. This specifies a really simple background with a paragraph, an H1 level header, a paragraph, etc. So there are a lot of ways of doing documentation. This is a pretty cool way. And if you want to, and I recommend you go through like the first 5 lessons of that, just to get yourself kind of familiar with CSS. This, again, I could be asking you questions about this, CSS and HTML. But none of this is all that complicated. It's just another markup language, right? The difference with HTML is that instead of having a line by line kind of orientation for your file, what you do is you have specifiers. So you can specify, for example, for a body type, you can specify a background color. This H1 specifies the properties for a header of level 1. P specifies the specifier for a general paragraph. And then you can do write code that uses those specifiers to actually change the styling. So we can make this green maybe. And if we change the styling for the H1 header, every place we've defined an item, an H1 item, we now get that in green. And you'll see that these items, right, it's really a very simple language. This is a start. This is the end, the corresponding end. And then everything in the middle there corresponds to an H1. And this is a P starts a paragraph, and then /P ends a paragraph, and everything in the middle there is another one. And we can put in like H1. Here's another. Right, so you just build this with these beginning and ending tags, right? Here's the start of the entire HTML document. Here's the end of the entire HTML document. Here's the front stuff. This will be like the style, titles, things like that. In the header, once we get through with the header, then we'll put our body in, and the body consists of one or more headers or 0 or more headers and paragraphs. Etc., all captured within these start tags and end tags. So it's just, again, another simple markup language. And yeah. Yep. All right. And if you look here, well, this is actually the source. This documentation HTML is actually in our repository, and this is the source for it, right? So we have our document type HTML. Here we go. Here's our header, right? Then we start the body. And every place where we have a section, end section, that corresponds to another slide in our documentation. So let's see, this is our documentation has 2 axes, right? We have some third level headers, and then some bulleted lists. See, where are we? We're right about here. Okay, so we're going to use a lot of these different tools, and the idea is you choose the tool both for what you're trying to show and for effectiveness in getting from what you want to show to the endpoint. So for us, using HTML allows us to do prettier slides than using restructured text or Markdown, but it comes at a price. It's a little harder to write. It's a little harder to understand. And by the way, we have a typo here that I will try to remember to fix. What time are we? So what we've done is I've provided. I'm going to take we'll take till quarter after. And why don't you guys take and kind of download this CSS and this sample file that uses it. And what you can do is you can actually go through and play with some of the setting up some of the headers and stuff. We have enough. Yeah, why don't you, I'm just going to give you about 10 minutes to kind of download this and play with it. Let's get some, let's do a little stretching. We are, I don't know, 45 minutes into this class. Let's take a little break, download this, play with it. The important thing we want here is that you can do some really cool things with these CSS files, and you can find CSS files all over the place. And then all you have to do is figure out how to actually make them make them work. Let's see. So I'll download this as well, I guess. I haven't played with this in a year, so we'll see if this actually works. Okay, so you don't need to spend a lot of time on this. I thought I changed that. We don't have to spend a lot of time on that, but just going in and searching for H1 and changing it from a nice muted gray to a fire engine red is pretty easy. Let's see. All right, I thought I made this 10 pixels, but maybe I didn't quite make that. Maybe it wasn't the thing that I thought it was. So the way I'm just doing this, there are other ways of doing this better, but I just simply do a Firefox. I think this one is called template.html. And then as you'd make changes to the underlying CSS, you should see things change in the actual code itself. So I can come up here. There's my underlying CSS. Let's see, can I? Okay, so that wasn't the piece that I thought it was. But just by searching for things like H1, right, we can come down and we can look at the places where H1 is defined, right, and change the color. I made it red. You can make it whatever color you want. Anyway, just we can go in there. We can change the different things in the CSS, and even though the web page hasn't changed, we can vastly change how the website is actually displayed to us. Anyway, I'm going to kill that. I'm going to kill this. There's a couple more languages we want to talk about. One of them is Latex. If you've done any scientific publications, I know that other things are getting better, but Latex is kind of the de facto way of generating documentation for scientific publications because it has really good support for mathematical formulas, etc. And there are things like what you see is what you get editors like Overleaf. I'm not really all that happy with Overleaf, but the idea is that if you create an Overleaf account, you can actually log into it, and you can do collaborative development of documents. This is a pay site eventually, but for what we're doing with it, it's free for now, and you can just come in and do things like change the author from Hello Kitty. I don't know why it's Hello Kitty. Probably somebody last year did this. Right, we can change that. We can recompile it, and we can bring it into didn't like that. There we go. Oh, I guess it was up further. We can come in here. We can change some of our formulas. Maybe maybe we had a mistake here. Instead of n+1, it was n-1. Right? We get nice presentation of our formulas. We can even make this two to the third power. It's really popular in the open communities. It's really popular among people who have to write mathematical papers. I think my entire thesis was written in it, but that was a century or two ago. You can embed nice little pictures. I did a lot of graphs this way. Do a graph under GNU plot, and then put them in as they as an image, generally a PNG or something. The cool thing is that if you're willing to pay for it and get advanced features, this will interface directly to GitHub. It's an easy interface to Latex. So if you don't want to do what I normally do with Latex, which is run PDF Latex on my files to generate and run it a couple of times because your dependencies get out of sync to generate a PDF from our LaTeX file. You can do this in the What You See Is What You Get editor, and then you can download it and run it on any LaTeX system. Here's another one. I'm going to recommend that you know a little bit about this. So you can come in here and we can do something like I'm probably going to get a lot of these. Right, so you can come through and generate all of your pictures in this, all of your images. It's a little bit of a nicer one in the fact that it is just pretty much free as far as I can tell. I should look into that a little bit more. At least it used to be free. Actually, Overleaf used to be free until they got too many users, and then they started making it not free. But anyway, that's kind of two different ways of generating tech online. Again, you can also just put it in a file and then run a tech compiler just like you compile. Sorry, I already did this part. Just like you compile a program. This is kind of the final segment in the documentation, so hopefully this isn't dragging on too long. But we've talked a little bit about the need for code to kind of exist. Oops. What pronunciation, Kevin? My bad pronunciation. Oh, as latex? Ah, yeah. You know, I think it's a clever play on words. If the whole open source community has a really bad sense of humor, or bad as in childish, and they like puns, like GNU is, GNU is not Unix, is it's kind of a play on words. The original system was called TEX, which is TEX, and Donald Knuth actually wrote that because he was writing his art of computer programming. So he wrote TEX so that he could. He didn't like any of the typesetting programs that were available to him at the time, and he certainly wasn't going to go back and do it the old-fashioned way. So he wrote TEX, TEX, and then we added stuff onto it to make it way more easier to use and to throw some engines in the front of it. And that's where LaTeX comes from. And I think at that point, somebody just, extended tech and put a play on words, but I'm not exactly sure. exactly the provenance of how it actually came to be. Like I said, it's just everything in Unix is a little bit weird sometimes. And thank you for answering the question about viewing the text slides as well. Anyway, so Knuth wrote books or wanted to write The Art of Computer Programming. I think I've seen interviews with him when he says that every year that passes, he gets another 13 months, I'm paraphrasing, of material he has to write. So he doesn't think he's ever going to be done, which is, understandable. It's kind of a cool system. I've got a couple of the books myself. I've got the first 4 volumes myself. But literate programming is kind of where all of this kind of heads. And the idea there is that you can, embed your code. You can write a document and embed your code within the document. So you're actually writing the documentation, but a byproduct of writing the documentation along the way is a piece of code that you can actually read and execute. And that's the whole idea behind literate programming, and kind of taken to its logical extreme. That's kind of what that's the ultimate synthesis of documentation with the programs. So it's kind of an interesting thought. It's where things, it's where the rubber meets the road that things get difficult, because nobody actually likes writing the documents. Everybody wants to write the code. So it's never really the case that the code gets written, or that the documentation gets written first and then the code kind of follows from it. You generally write the code and then you try to write the literate programming around it, the literate document around it to make it make sense. But literate programming is something you should be aware of. R has a couple of ways of doing dynamic report generation, including this thing called knitr. So it's markdown document with R chunks integrated in, so you can write something and then inside your text, you can actually, I thought this had a better example, but throughout your text, you can actually see the code. We'll deal a little bit with R when we talk about statistical programming, but the place we really want to kind of go to is in Jupyter Notebooks, because Jupyter Notebooks are really kind of a nice way of doing literate programming using Python. So if you read down through here, I'd recommend reading at least down through the literate programming block. It's not that long, but they talk nicely about that. And in fact, I owe you guys a reference here. One of my students, my master's students, did his entire project in Jupyter Notebooks, and I meant to put that on my drive, so I had it here, but I have to find it. So, but the concept here, again, is just like with R and with Knuth's text stuff, is that you can actually write a document and embed little snippets of Python that implement your different steps along the way, and then somebody reading the document can execute those, assuming they have the right Python environment, and actually generate your results along the way. So if you read in a lot of disciplines like psychology, 30% of the research can't be replicated. When they rerun the experiments, or I'm sorry, only 30% of the research, and that's a fuzzy number. It may be up, it may be down from there, but a significant percentage can't be replicated. So only 30%. So that would mean about 70% of scientific studies in some fields can't be replicated. So that's not good, right? Because that means that our whole idea on doing research and development is that you should be able to get a result, and if the result has meaning, then the next person in should be able to build on your results by replicating your experiments and taking them in a different direction or exploring different fields from that. If 70% of the material can't be replicated, then you've kind of gotten yourself in a hole. Well, literate programming, particularly in research, kind of gets around that entire issue because when you write your literate program, you write the document, you write the text of the argument of your paper, but you also intersperse there the code actually needed to generate your results. So open source software, again, it depends on open source software because you're not going to publish a paper, literate or not, with your results if you're not willing to publish your source. So, in an open environment, using literate programming, you can actually write results that have to be 100% reproducible, or that can be debugged so we can figure out, is it something you had on your system? Is it the way you used your data? It can automatically be applied to other sources of data. So if we're trying to remove data bias, or if we don't believe you have good data, or we have new data coming in, right, you should be able to run exactly the same code on it. You're not dependent upon my being able to recreate your code based on what I've read in an 8-page paper, right? You spend a year writing a bunch of code to carry out an experiment or to do something, and then I read it, and I'm supposed to try to replicate it based on your descriptions over, 8 pages in general. And that's very difficult. Whereas here, I can just come in and run your stuff directly, and then if I want to deconstruct it, I have a baseline to go from where I can actually modify or compare or improve upon. Okay. And I should have done this instead of looking for all of those other papers. But this is Peter Norvig back in 2016. There's an advent of code solutions. Morthy follows these religiously and does his own notebook or does his own solutions. But Peter Norvig, who's kind of in this area, decided to do his advent of code as a Jupyter notebook. So this is what a literate program kind of looks like, right? So here he's kind of describing stuff, right? And then down here, well, this is his getting ready. So he has some favorite Python files that he uses. They're all in here. They're all in something that can actually be run as part of this Jupyter notebook, right? So you can actually execute all of these and run them as the Python and actually get the Python out. And then you can actually run some tests to make sure that all of the base code that he wrote actually works. Here's the first one, right? Here's his discussion of the puzzle. Here's his solution to the puzzle. And here's the output from his solution, right? And again, part 2, talk about it, write the code for it, get the output from it. So it's just a nice little illustration of what a good, literary discussion of code can actually look like if you are doing it in a literate programming kind of fashion. Feel free to download that and play with it. It's kind of fun. Okay. So we've talked about a bunch of documentation, and we've talked about it kind of as a straight documentation thing. But the idea here is a couple of things. One, you want to communicate information, but the other part is you want to get the community involved. And you can often get the community involved by going to some other types of not necessarily documentation, but information kind of channels. Quora, Reddit, Stack Overflow, right? If you have a sufficiently popular open source community and you're willing to have somebody answer questions in Stack Overflow, right? That's the first place most programmers look for help. Or at least it's well indexed by Google. And you can also have online mailing lists where you kind of just reach out to people. And the idea is you want to build up community and you want people kind of working together on that. All right. That's the end of part 1. Let's sit up. We'll do a little stretches for now. Let me see if I get back to a different screen. Come on. Do a little stretches, kind of bounce, do a little twists. Let's get ourselves loose for part 2. Part 2 is a lot faster. but we will go there momentarily. All right, so let's look at part 2.